In this video, we're going to talk about simplifying rational expressions. These are practice problems. It says section 5.7, but in the newest book, this is section 5.8. So we're going to start here with number 1. Simplifying rational expressions is basically what we would call reducing. And since this is a basic fraction, we're going to reduce these just like we would in algebraic rational. We're going to separate the numerator and denominator into their prime factors. So 77 is 7 times 11. The 7's reduce, but that doesn't mean there's 0 on the top. Anytime you reduce, you're making 1s. So this is 1 over 11. And number 2, the prime factors of 50, 2 times 5 times 5. And if you need to do it off to the side, go ahead and make your tree. The prime factors of 75, 3 times 5 times 5. Reduce the factors that match. You're left with 2/3. And number 3, we've got some variables going on. So you can break these up. 21 is 3 times 7. Then we have x times x times x, x cubed, and y squared. 6 is 2 times 3, and there's 1x and 4 y's. Then we can reduce these 3's, we can reduce an x, and we can reduce 2 y's. That leaves us with 7 times x, or 7x squared in the numerator. 2 times y, or 2y squared in the denominator. On number 4, we're going to do the same type of thing. We're going to first use prime factors for 36. That's 2 times 2 times 3 times 3. And x to the 5th would be 5x's and y cubed over 72, I know, is 8 times 9, and 8 breaks down to be 2 times 2 times 2, and 9 is 3 times 3, and then 4x's and 3 y's. It's okay if you need to pause the video and do your trees. It's perfectly fine. Pause the video, do your trees. Not everybody is as quick with these as I am, but I've been doing a lot of these. I've had a lot of practice. You need to probably do the trees, so just pause the video, do the trees. So then we can reduce some of these. Anything that matches on the top and the bottom, you're just reducing to make 1. So what are we left with? In the numerator, it looks like we're just left with an x. In the denominator, we have a 2. Is that it? That's it. So we have x over 2. On number 5 now, all of a sudden, the type of problem changes now because we have included this addition or subtraction here. So we can't just stretch out the factors like we did here. This only works when we have monomials. Everything is being multiplied. When we start putting addition and subtraction in the numerator or the denominator, now we need to use our polynomial factoring, which means you're going to need to go back to, if you don't remember factoring, go back to the previous lesson because you're going to have to follow all the steps for factoring the numerator and the denominator here. The first thing we look for with factoring is a GCF, and it does look like they have an x in common. So when we factor out the x, we're left with x minus 3. The denominator here is just x minus 3. There's nothing there to factor. There's no GCF. It's not the difference of squares. And then we can reduce off the x minus 3's that match, and we're left with just x. On number 6, the numerator is a monomial, so it's okay to use prime factors, just factor it out. The denominator is a binomial, so we need to look for the difference of the GCF first, and then we'll see if we have the difference of squares. The GCF here is 5x. So when we factor out a 5x, we're left with 5x minus 6. Remember, factoring out the GCF is the same as undoing distributive property. So it looks like the 5 and the x will cancel. This does not come out to be 5x minus 6. You do have a 5x minus 6, but it's in the denominator, so you have to have the 1 from these still left in the numerator. You can't drop the numerator of a fraction. So don't make the mistake of just writing as 5x minus 6. It's 1 over 5x minus 6. All right, factoring out the GCF in the numerator, we'll have an x, and that will be times x plus 2. The denominator is a standard trinomial, so it should factor into two binomials. X squared is x times x. Bring your signs down, plus plus. Factors of 2 that add to make 3 are 2 and 1. And then you can reduce off x minus 2's. So it looks like you're left with x over x plus 1. And again, just like I said in the lesson, these x's will not cancel off because this one has the plus here. It's a term. This is a factor, and this would be fine if I had just a factor down here, but since this one's a term, it cannot cancel with that one. Okay, so it looks like in the numerator here, we have 4 terms. So we're going to do factoring by grouping. So I think I'm going to carry this down here and rewrite it. So we got x squared plus 3x plus xy plus 3y, and I'm going to cut this in half, and I'm going to factor by grouping. So in the numerator here, in the front here, we have a GCF of x. When we factor that out, that leaves us with x plus 3. In the back here, we have a GCF of y. When we factor that out, we're left with x plus 3. And now we have a common binomial of x plus 3. So we're going to bring that to the front, and that will leave us with x plus y in the other binomial. So the numerator here factors to be x plus 3 times x plus y. The denominator is a standard trinomial, so we should be able to factor it in one step. X squared is x times x. Bring down the first sign. Multiply the two signs for the second sign. Positive times positive is positive. So we're looking for factors of 6 that add to make 5. That would be 3 and 2. And now we can reduce these x plus 3's off. And we're left with x plus y over x plus 2 from these. Again, don't cancel these x's. They do not cancel when they have an addition to something else. They're a term. And you cannot cancel terms. You can only cancel factors. All right, on this page, we're going to continue on with simplifying rational expressions. On number 9, the numerator is x plus 3, which doesn't factor. There's no GCF. It's not the difference of squares. The denominator is a standard trinomial. So we're going to factor this as a standard trinomial. X times x plus, and don't forget, positive times negative makes negative, so this will be a negative over here. So we have different signs now. So we're looking for factors of 6 that subtract to make 1. That would be 3 and 2. We always write the biggest one first, especially when we have different signs. And now we can cancel off this x plus 3. But again, don't forget, you still have the 1 up in the numerator, so this is 1 over x minus 2. Number 10, 2 standard trinomials in the numerator and denominator. So we're practicing trinomial factoring here. So the signs will be negative, positive. So we're looking for factors of 15 that subtract to make 2. That would be 5 and 3. In the denominator, the signs will be negative and negative. So we're looking for factors of 15 that add to make 8, and again, that's 5 and 3. So we can cancel these x minus 5s. And that leaves us with x plus 3 over x minus 3. Do not make the mistake of canceling these. These x's are terms and these 3's are terms. They cannot cancel. On number 11, the denominator is another standard trinomial. So let's start with that one. We're going to have x times x. We've got a negative and a negative. So factors of 16 that add to make 8 will be 4 and 4. The numerator, though, is not a trinomial. It only has 2 terms. There is no GCF, so we're looking at the difference of squares here. Remember the perfect square minus the perfect square. And this is just a pattern that you had to remember. Again, if you don't remember this, go back to the lesson on factoring difference of squares. This comes out to be x plus 4, x minus 4. And these will reduce. So we're left with x plus 4 over x minus 4. Again, don't try to reduce these x's or these 4's, because once you have them in the binomial with the add and subtract, they don't reduce. Number 12. In the numerator, we have a trinomial, but it's not a standard trinomial because of this 2 here. We're going to use square root factoring because of this 2. In the denominator, I see a GCF. So I don't know which one you want to start with. Let's start with the numerator. We've got 2x squared plus 11x plus 5. Because of this 2, we're going to do square root factoring. So that would be 4x squared plus 11x plus 10. If you know the AC method would also work here. In my lectures, we use the square root method. If you don't know how to factor this, you're going to need to go back to a factoring lesson, because these are not videos. This is not a video on factoring. This is a video on simplifying. So we have our signs in, positive times positive. So same signs mean we're adding. So we're looking for factors of 10 that add to make 11. And that will be 10 and 1. Don't forget the last step where you have to divide off the GCF. So both of these divide by 2. That leaves us with x plus 5 over times 2x plus 1. So that's the numerator, x plus 5 times 2x plus 1. The denominator, I'm just going to draw a line here. Let's put the denominator over here, is 2x squared minus 50. There's a GCF there of 2. And once I get that GCF out, now I have a binomial that's the difference of squares. So my GCF is still out here, and the difference of squares here is going to be x plus 5, x minus 5. So this is the denominator, 2 times x plus 5, x minus 5. And now I can cancel or reduce the x plus 5s. And I'm left with, in the numerator, 2x plus 1 over, in the denominator, 2 times x minus 5. And I'm going to say this again. These 2's are not going to cancel. This 1 in the denominator is a factor, but this one up here is a term. So you cannot cancel that like that. All right, number 13. It looks like, again, in the numerator, we're going to use our square root factoring. In the denominator, we have a standard trinomial. So let's start with the denominator. Standard trinomial factors in one step. X times x, first sign, and then multiply the sign. So we have different signs. So factors of 21 that subtract to make 4 are 7 and 3. In the numerator, let's pull this down here because it's going to be several steps. 3x squared plus 13x plus 12. Multiply the first and the last terms both by 3. So 9x squared plus 13x plus 36. Square root the first term. So we have 3x times 3x. Bring your signs down, plus and plus. Factors of 36 that add to make 13 are 9 and 4. and then we divide by the GCF. So that gives us x plus 3 times 3x plus 4, and that's the factors for the numerator, x plus 3 times 3x plus 4. And when we look at this now, all the factors are laid out, we can see that the x plus 3's will cancel. It doesn't matter that they're not right on top of each other. So our final answer is 3x plus 4 over x minus 7. All right, this is the last one on this page. And both of them are going to require the square root factoring. So we'll start with the numerator. Let's bring it down here. 6x squared minus 7x minus 3. You need to multiply the first and the last terms both by 6. So 36x squared minus 7x minus 18. And then square root the first term. The square root of 36x squared is 6x. Bring your signs down. They'll be negative, positive. Factors of 18 that subtract to make 7 are 9 and 2. And then divide off the GCF of each binomial. So both of these by 3, both of these by 2. That leaves you with 2x minus 3 times 3x plus 1. That would be the numerator. 2x minus 3 times 3x plus 1. The denominator, let's draw a line. Let's do the denominator over here. 8x squared minus 6x minus 9. So we need to multiply the first and the last terms both by 8. So 64x squared minus 6x minus 72. And then square root the first term. The square root of 64x squared is 8x. The signs are going to be negative, positive. So I'm looking for factors of 72 that subtract to make 6. You might want to make a list off to the side. You know, start with your 72. What numbers make 72? I happen to already know that this is 12 and 6. If you don't know that, then you're going to need to make a list. All right, divide by the GCF. Here is 4, and here it's 2. So 2x minus 3 times 4x plus 3. And we'll write that here in the denominator of our original rational expression. So I'm putting the denominator up here. 4x. Now we can see the 2x minus 3's are going to reduce. Just like that. And we're left with these two factors here. So if we have room, yes, we have room, we'll write our final answer over here. 3x plus 1 over 4x plus 3. Do not try to cancel these 3's or these x's because they're all part of a term. Okay?